new 737 MAX.
Vast similarities to the older model. It felt in some ways a bit smoother, natural to the touch. So compliments to Boeing for whatever control laws they put in. They got it done. So it was an enjoyable airplane to fly. The displays are different, so you have to get used to that. We received about 56 minutes of an iPad lesson, and we're told you're good to go to fly the aircraft. We've since had a different opinion on this.
157 people died. This was just a few months after another flight, Lion Air 610, crashed in Indonesia and killed 189 people. These two flights were operating the same plane, the Boeing 737 MAX 8. And its engine is the key to understanding why this particular plane has caused so many problems. But there's nothing actually wrong with this engine. In fact, airplane manufacturers raced to put them on their new planes. That's where the problem started.
I'm Dennis Tager, captain on the 737 at American Airlines and spokesman for the Allied Pilots Association. I have about 10 years of flight experience on the 737, and I fly both the NG, the previous model to the MAX, and the MAX. Because the way the MAX has been designed, it has larger engines, they're more forward on the wing, and the wing is a little bit different. The bottom line is the aerodynamics are such that when you go to recover from a stall, you're going to push the nose down and apply power, and those engines have a pendulous effect and can cause the nose to come up. When you're in a stall, an aircraft wing stops flying, it means you need to get more airflow over the wing. So you have to push the nose over, and that's all part of that, and that's what the MCAS does. MCAS, Maneuvering Characteristic Augmentation
The two biggest airplane
System.
manufacturers in the world are Airbus and Boeing, and they have a fierce rivalry. If one of them can offer a better plane, the other could lose a lot of money. That's exactly what was about to happen in 2010. Airbus announced that they would update their most popular model, the A320, a single-aisle airplane that services many domestic flights. You've probably been on one. To compete with Airbus, Boeing's obvious move was to upgrade the engine on their single-aisle plane, the 737. But there is one issue. Here's a sketch of the 737 next to the Airbus A320. Notice how the 737 is lower to the ground than the A320. This meant Airbus could slide a new engine under the wing of their A320, but there wasn't enough room under the wing of the Boeing 737. But a few months later, Boeing's product development head had big news. He said, "We figured out a way to get a big enough engine under the wing." Their solution was to move up the engine on the wing so that it would be slightly higher, and it would fit on their 737s. Except moving the engine up on the 737 had a side effect. When the 737 MAX was in full thrust, like during takeoff, the nose tended to point too far upward, which could lead to a stall. This was a problem because these planes were supposed to behave exactly like the old ones. So Boeing came up with a workaround. Instead of re-engineering the planes, they installed software that automatically pushed the nose downward if the pilot flew the plane at too high of an angle.
The MCAS will trigger for 10 seconds down very rapid trim to help you with a stall that it's not having. And then within about 2 seconds or 5 seconds, it'll come right back in and do it again. So this is the pilot probably not knowing that that's happening and then pulling back up in that interim period where it's not activated, but then the MCAS comes right back in and points that nose down again. So until and unless you determine that that system, which you don't know about, is running the trim, then you would disconnect those two switches. Now the trim system is no longer functional and the MCAS has no toys to play with. That's how you save that aircraft. But if you don't know that information, you see what the likely outcome is.
Didn't mention the MCAS software. In 2018, several American pilots complained to the federal government that the 737 MAX was suddenly nosing down. On October 29, 2018, Lion Air Flight 610 took off from Jakarta. In the flight report, which shows the plane's altitude over time, you can see that the plane was in full thrust during takeoff. But at a certain point, the nose of the plane kept lurching downward. The pilots couldn't figure out why this was happening. The captain asked the first officer to check the quick reference handbook. They couldn't find the solution. The pilots continued to fight with the MCAS. The plane struggled to gain altitude. Reports show it was likely because the computer was getting incorrect sensor data, pushing the plane toward the Earth below. 12 minutes after takeoff, the plane crashed into the Java Sea. In the Ethiopia crash, the report shows that the pilots were actually able to disable the MCAS, but it was too late to overcome the malfunctioning MCAS sensors.
The malfunctioning sensors were angle of attack vanes that were on either side of the cockpit. They were either incorrectly installed or malfunctioning. Boeing offered a safety fix for this as an added option to be purchased. The cause of the accident would have been eliminated had this been on the airplane.
For now, nearly every 737 MAX 8 in service has been grounded, and the Federal Aviation Administration is facing scrutiny over how they rushed this plane through certification. Boeing's response has been to apply a software update that makes the MCAS less aggressive, while also saying they'll increase pilot training on how to turn it off. This problem started with the company's race to compete with its rival. It pushed them to pretend like their new plane behaved exactly like their old one, even when it didn't.